Okay, so Chapter 11 deals with surface area and volume of three-dimensional figures, and kind of a quick review of that is dealing with some of the basic figures of using surface area and volume of prisms, whether they're rectangular or triangular. So something you've done in the past and previous years is finding surface area. And remember, surface area deals with the area of all the faces of a figure added together. So there's multiple ways to do that. One is to just find the area, like 2 times 12, this side is 24, and 4 times, that's a length of 2, so 4 times 2, that side is 8, and over here you also have another side, and that's 8, and then you have the back side of that, and that's 24, and then you have the top and the bottom, which you have 4 times 12, or we think of the top, 48, and then the bottom, 48 as well. And then you add all those things up. So you'd have 8 plus 24 plus 24 plus 48 plus 48. Oh, and I forgot that other 8 there. So a total of 6 faces, six different measures, and that is 160 square inches. Now, that's one way to do it. It's not always as easy. Like the prisms change. So, like when you're dealing with this prism right here, it's a little harder to find the area of all the faces, but you could still do it. We call each side a face there. Another way to do it to find surface area is you could take the perimeter of the base. So the perimeter of this base right here, 12 plus 4 plus 12 plus 4. So if you take the perimeter of the base and you multiply it by the height, so 12 plus 4 plus 12 plus 4, or 32. Okay. And then multiply it by 2, which is our height. That right there is 64. And then add the 2 bases in, the area of this base and the area of the bottom there. So the top and the bottom. So if we say perimeter times height plus 2b, where b is the area of the base, that's another way to find the surface area. In fact, that's kind of the more common way of doing that. This right here gives you what's called lateral area. And then you add in your area of your 2 bases. Okay, so rather than having the 64 we had another 96 to that, which brings you to your 160 square inches. Same thing. A lateral area is just like if you had a wrapping on the box. Or if you think of, probably the easier way, if you think of a cylinder, maybe like a soup can or something, the wrapping on the outer edge is your, like the labeling on the outside. That's your lateral area. Okay? So when you're finding perimeter times height, you're finding the lateral area. And then you add in the area of the bases. How many are familiar with the surface area? How many have seen this formula before? Okay, note why it works. When I'm saying, notice on 24 here, I did 12 times 2. And then this 24, I did 12 times 2. And this 48, I did, oh, let's ignore the 48s for a minute because those are the bases. The 8, I did 4 by 2. And this 8, I did 4 by 2. What do all those things have in common? They're all multiplied by 2. So algebraically, what we could take out of each of those is a 2. And you'd be left with 4 plus 4 plus 12 plus 12. Well, that 2 happens to be your height. And this 4 plus 4 plus 12 plus 12, well, that's 12 plus 4 plus 12 plus 4. That's the perimeter of your base. That's why that formula works. The hard thing for some students is to figure out what the bases are. So when you're looking at this figure, go ahead and tell your neighbor what your base is. Like, what shape is the base? Everyone agree it's a rectangle? Okay, and that would be wrong. The actual base is this triangular face. Okay, when you're dealing with a prism has two shapes that are connected by a bunch of rectangles. When you're dealing with a prism, the part that is your base is the part that is not rectangular. Now, when you're looking at this prism, everything's a rectangle. So you could actually, any of those could be your base. Okay, but when you're dealing with a triangular prism, the triangles, the two congruent faces that are connected by rectangles, happen to be your base. So if I'm using this formula here, perimeter times height plus 2 times the area of the base, this is the perimeter of the base. So the perimeter of this base, everyone tell your neighbor what you get for the perimeter of the base. All right, what is the perimeter? 36, 10 plus 13 plus 13, yeah. It's 13 over here. So 36. What's the height of the figure? The height connects the two bases. Nope, that's the height of the base. Yeah, it's 15. The height connects the two bases. Okay, so that's the height. What's the area of this base? Area of the base is base times height divided by 2, right? Yeah, so it is 60. Okay, so we end up with 60 there. So 36 times 15 plus 2 times 60, we end up with 5, I think that's 540, 120, 660. All right. Guys, that is a really quick review of surface area. All right. Questions? Okay, I want to make sure you've answered question 3 and 4 with your groupies there. A lot easier now, right? Compared to what you were just doing. So 5/2 of an inch, or 2.5 inches. Okay, how do we find area of a triangle again? Good, base times height divided by 2, or 1/2 base times height. Okay, area is 32. The base is 8. What is the height? Half of that is 4, so we get 4h equals 32. H is 8. Yeah. Good. All right. Very good. Take the note page you picked up on the way in, or pack there where you can take notes. And example 1 here says, find each indicated measure. So this is 10 point or 11.1. Dealing with circumference and arc length, okay, using the formula for circumference. Circumference of a circle with a radius of 9. Does it? Tell your neighbor how to find circumference. Anyone know? No. Yeah.
Pi d or pi r squared.
Good. Pi d or not pi r squared. Pi r, 2 pi r. Yeah, 2 pi r. Now, Mr. Vogel likes to say c d pi, e d pi. That helps him remember that. C d pi, e d pi. Some of you are like, you don't get it. Or 2 pi r better than 1. 2 pi r better than 1. Some of you guys you're like so boring. Or like when you say pi r squared. No, they're not. Pi r round. Gee, unbelievable. All right, well, whatever. These are your two circumferences. Hey, the circumference of a circle with radius of 9. I want everyone to figure out that. Go ahead and put it in terms of pi, which means you leave pi in your answer. And then, after you've done that, I want you to round it to the nearest hundredth. Okay? And then part B, the radius of a circle with circumference of 26. Off you go. When you calculate this, make sure you're using the pi button. Do not just put 3.14 in. Forgot. What do we want around here? Oh, I did say the hundredth. Okay, hundredths. Let's go with hundred. Okay, circumference of a circle with radius of 9. So which one would I use? Yeah, 2 pi r. 2 pi r better than 1. Yeah. Okay, 2 pi times r, which is 18 pi's. That's leaving the answer in terms of pi. And then if we round it, you have to take one more step. 18 pi is, there we go. It is a linear measurement. Please remember that circumference is the distance around a circle. So if I'm taking a look at that, the circumference is how far around the circle you go, which is a key piece when you start studying radians, which actually we touch on radians today, but go talk to one of your classmates that's in trig and how much time they've spent studying radians the last couple days and how it relates to circumference of a circle. Okay? A really big deal. Okay? They started that this week. Or you could just go online and watch my video from 9.2 for trig. All 2 of them. All hour worth. About an hour's worth of video. Fun stuff. They love it. Okay? All right. 56.5. So which would you rather leave it in terms of pi or decimal? Who wants to go decimal? You're like, I like decimal. How many want terms of pi? Which one's faster? In terms of pi, right? I mean, if I say leave it in terms of pi, you should be like, woohoo! Yeah, man. I don't have to use my calculator at all. I know some of you do this in your head, but... Okay, radius of a circle is the circumference of 26. Okay, now we're just plugging in. Right here. 26 is equal to 2 pi r. How do I find the circumference or the radius? Crickets, man. Divide by 2. What else? Yeah, divide by 2 pi. They're multiplying by 2 pi. That cancels that. 26 divided by 2 pi is approximately, first it becomes 13 over pi, right? The same as 13 over pi because the 2 cancel or reduces 26. 4.14?
No, 48.4 is what I got. That 13 by this.
Okay, do this for me. It should be 4.14. For those of you that put this into your calculator as 26, if you ever do 26 divided by 2 pi, like that, you're going to get that. And now I just said the answer was 4.14. What did I do wrong? Yeah, it's doing 26 divided by 2 times pi. Your calculator's reading this as 26 divided by 2, and then it's multiplying it by pi. Because this isn't in parentheses. So you'd have to put like that. Okay? Yeah. Sometimes people think their calculator's broken. They're like, dude, my calculator's broken. All right. Okay, hey, if you want more practice on that, there's some monitoring progress. You can do those on your own. Let's go on to example 2. Find the indicated measure, the arc length of AB. Please note that the arc length is different than the arc measure. This arc measures, the measure of arc AB is 60 degrees. The length of arc AB is a part of a total length around the circle. It's a linear measurement. It would be like in centimeter form. So note the difference in wording. The length means the actual distance. If I was to take a string and lie it on the outer edge. The measure would mean the angle measure. Okay, so go ahead and figure out part A there. Work together, come up with a plan of attack. Hey, the arc length. Hey, this length is a part of the overall circumference. Right? So if I was able to find the circumference, and multiply it by what chunk of the circle, what part of the whole circle is this? It's 1/6. How did you get that? Yeah. 60 divided by 360. So this is the part of the circle that we're dealing with. Okay, so it's 1/6, right? That reduces to 1/6. So 1/6 of the circumference would tell us what AB is. Well, the circumference is 2 pi r, which means we have 1/6 of 2, or 2 times 1/6 is 1/3. And then our radius is 8. So we get 8/3 pi. Dude, what's 8/3 pi? Let's approximate it. 8/3 times pi. .3. Okay, so 8.38 if we round it. Okay. Hey, let's try letter B. Circumference of circle 0, or circle Z, excuse me. Okay, so we're using that same formula. We know that xy is equal to whatever the part of the circle is. What part are we dealing with? 40 over 360 times the circumference. What's our circumference? 2 pi. Yeah, we don't know. Dude, we better just leave that as circumference right now. Do we know xy? Yeah, we can actually plug that in. That is 4.19. So to find C, yeah.
Why don't you just cross multiply and divide?
Good idea. Let's cross multiply and divide to find C. Or we could just multiply by the reciprocal to move that over. So we go 360. Let's reduce this. That's ugly. What is that? 1/9. Thank you. So let's multiply 4.19 by 9, the reciprocal. So our circumference is 37.71. So you've got to use what you know to find what you don't know. Any questions on those two? How about RS? We're using that same formula. It's just now, we're using RS because it's a minor arc. So we know RS is equal to whatever the part is times the circumference. So out of all those things, do we know RS? Yeah, 44. Do we know what part of the circle we're dealing with? Something over 360, right? They're actually asking for what the measure is. They're asking for what is this angle. That's the measure. So we're going to put an X right there. We don't know the angle. And then do we know what the radius is? Yeah, 15.28. So from there, you just have to solve it up. Okay, it's doing the math. Everyone calculate what you get, at least on this side of the equation. For those of you struggling, that's a big fraction there. So all that's on the top and 360 is on the bottom. So I get 30.56 pi x, which is kind of ugly. All over, or all equals 44 over 1. So from there you cross multiply. What's 360 times 44? 840. And that's equal to 30.56 pi x. If I want to get x by itself, what do I have to do? Divide by 30.56 pi. That's going to tell me what I need there. That cancels. I'm going to write it over here. X equals, or is approximately, okay, 164.98. So let's go to 165. 165 degrees. Carlos' question is, could we just set up a proportion where we say like the arc length of RS? Make sure that I'm putting this right. Over 2 pi r, right, the circumference, is equal to what now?
The measure of the arc.
Okay, the measure of the arc. Yeah, you for sure could do that. So like, if we want to say the measure of arc RS. That would be just fine as well. And if you do that, it really what it does, it brings you to right here. Or, excuse me, to right down here. Okay. Yeah, that would be fine. Setting up a proportion like that. Okay, I want you to turn the page, please. Okay. There's example 3 and example 4. I want you guys to just look at those. Take a look at example 3. You talk to your neighbor about it real quick. I'm going to be handing out your assignment. Okay, so you've read through example 3. I want you to take a look at example 4. Read through that. This actually says, it's hard to read that. It says 44.02 and this says 36.8. Okay. But these two examples are also in your textbook.
Does red switch lane?
No. No, they're just standing there. Dude. No, they're not switching. All right, now I want you to turn the page and look at example 5. This is really where I want to get to right now when you're dealing with radians. A radian is taking when you're dealing with a radian, you're taking your circumference and the radius you have, and you're basing, rather than basing on angle measure, you're basing on how many radii will fit around the outer edge of the circle. So you're measuring your circle based upon the radii that you stretch along the outer edge. Okay, so really what you could do is if I'm trying to figure this out, if I were to say circumference is equal to 2 pi r, and I say that the radius is actually 1, in what we call the unit circle, which is what you'll study a lot in trig, which is where we use a lot of radians, we have a 1 unit radius. That means circumference is equal to 2 pi radians. That means there are 2 pi radians, or about 6.28 radiuses that would fit along the edge of any circle. So no matter what circle you have, if you were to cut out the radius and lie it along the outer edge, about 6 1/4, it would take about 6 1/4 radiuses to fit around that circle. Okay? No matter how big or small, because size are proportional. Okay? So what you've got here is if you're converting from degrees to radians, if one whole circle, if 360 degrees, which is the distance around a circle, is equal to 2 pi radians, what is 180 equal to? It's equal to 1 pi radian. So when we're converting between radians and degrees, and you guys that have dealt it with your calculators, you go mode and we're in radians. And I always tell you to switch to degrees. That's what I'm talking about here. So when I'm converting from radians to degrees, I am going to use this proportion. Now I know up here it says 2 different ones. You can kind of ignore this and just use pi over 180. Pi is to 180. That means I have radians on top and degrees on bottom. And if I'm converting 15 degrees to radians, I'm going to put a 15 right here. And I'm going to put an x right here. I'm going to find the number of radians. Now how do you do that? Cross multiply, yeah. 15 pi is equal to 180x. Divide by 180. You get x is equal to 15 pi over 180. Now we want to leave it in terms of pi. We don't want to change it to decimal. So reduce it. 5 goes into this 3 times. Does 15 go into 180? Yeah, it actually goes in. How many times? Yeah, 12. Okay? So that's pi over 12 equals x. So 15 degrees is pi over 12 radians. If I'm going the other way, I'm using the same formula. Pi over 180 is equal to 4 pi over 3 radians over x. And now that's an ugly fraction. So when I cross multiply it, it's 180 times 4/3, or 180 times 4, which is 720 pi over 3 equals x pi. Now if you want, you can cross multiply again. 3x pi is equal to 720 pi. And divide by 3 pi. You get x is, well, 72 divided by 3 is 24 with a 0, 240 degrees.